This is the Turbulence race plane. For this project, I focused mainly on speed and not on craftsmanship. The plane is a copy off of Mike Patty's highly modified Lancer Legacy. The build starts with the wing. It has two strong basswood spars and a symmetrical airfoil. Next comes the fuselage. The fuselage is built in two halves, using plywood bulkheads, which are joined with balsa strips for their combined. Here's a mock build of the plane, roughly halfway complete, then the initial nearly finished product. I made the color scheme rather simple in an effort to distinguish the top from the bottom mid-flight. Here we have the hatch, with all the electronics as far forward as possible, and the battery in the back as tail weight. After flying the plane for the first time, I made a few changes. First, I put on a larger nose cone, which increases the plane's top speed quite a bit by reducing drag. Then I added a folding prop. After realizing the centrifugal force of the prop windmilling when landing resulted in the prop breaking nearly every time upon touchdown. Now we have the wing angle of attack. I initially planned to build the plane with about 1 to 2 degrees of upward tilt in the wing. I later learned that the intended speed of the plane plays a big part in how angled the wing should be, and it should be designed accordingly. Here's a wingtip. It's solid balsa sanded to shape with a streamlined aerodynamic design to reduce drag. Here we have the trailing edge of the wing. In theory, it should come straight to a point, but some complications along the build process didn't allow so. But that would make a great modification for another prototype of the plane. For the ailerons, I ended up using a single servo to save on weight. The elevator and rudder servos are in front, with their push rods following the fuselage through pre-drilled holes in the bulkheads. The hatch is solid balsa, which I sanded to shape by hand. 2 wood dowels slide into pre-drilled holes in the front. Then, a pin on the back slides into another pre-drilled hole and is held in place with a magnet. Lastly, we have the tail. Both stabilizers and control surfaces have been sanded to a thin airfoil to reduce drag. They also have large control surfaces for good control at slow speeds during takeoff and landing, but are dialed down during high-speed flight to reduce flight sensitivity. Here we have the flight.
That was a good one.